Welcome back to NEET World. So this is our day 5 of EAPCET 2026 series. So in the last 4 classes we have completed mole concept, that is some basic concepts of chemistry, and as well as periodic table and its classification properties we have discussed along with some PYQs. Okay, so in this particular session I am going to discuss the previous year questions from those 2 chapters. Okay, so this session is completely dedicated for PYQ questions only, like only question solving here, questions discussion only. Okay, so if you haven't watched our previous live sessions, you can go and watch those, so that definitely useful for your preparation. Okay, so look at this first question here. We have the question based on simple electronic configuration. See, every student, those who are preparing for any exam based on your 11th, 12th, even if you are 10th, you need to know the electronic configuration, right? So what is the general electronic configuration of alkali metals we have? So it will be NS1 right now. So it means alkali metals NS1. Similarly, alkaline earth metals will be having NS2 electronic configuration now. So it will be third option. Next, halogens will be having NS2 NP5, right? So C. Okay, and noble gases completely filled NS2 NP6. So this is a very simple question now. So this is how you need to answer this simple question based on the knowledge you have. Okay, so again I am saying you, so if you haven't started your preparation for EAPCET 2026, whether you might be from Telangana and AP, okay, so you just start the preparation with the help of our NEET World YouTube channel. Okay, so because we have provided free live sessions in the last academic year also for 2025 EAPCET, so same will be continuing this year also. We are coming up with free live sessions for EAPCET 2026 preparation. Okay, so next question here we have the change in enthalpy delta H for a reaction is, see, they have given a reaction like this and they are asking what is the change in enthalpy. So very simple now, look at this. For the formation of MgF2, we required magnesium ion. So magnesium plus 2 ion that comes from Mg, right? Mg plus 2. So during this process, what are the things involving? So first of all, magnesium need to convert into gaseous phase. That is what first ionization should be happens and should convert Mg plus 1, and then next from here to here, this is second ionization. So IE1, IE2 is involved. Okay, and along with this, 2 fluorine atoms should convert into fluoride ions. So right now, so total process here involved will be, so enthalpy change during this process will be equals to IE1 of magnesium plus 2 plus IE1 of magnesium and IE2 of this magnesium. Okay, you take these 2 values plus what is the other thing involved? Electron gain enthalpy of fluorine atom here. How many fluorine atoms are there? 2 atoms are there. So 2 multiplied with electron gain enthalpy, here they have mentioned, see, electron affinity is 340, 328 for fluorine. Okay, so for 1 fluorine it is 328, and we know electron affinity, these values are in negative terms right now. So you should take 2 into minus 328. Okay, so like this we need to take. So now try to simplify this. Value. See, I am taking here electron affinity, 2 times of electron affinity of fluorine. So substitute these values. So first value here it is for fluorine it is plus 2 into minus 328, and this IE1 is given as 737 plus, and what about this IE2 value? It is 1451. So by simplifying this, we'll get answer as plus 1532. Okay, so 1532 will be our answer. Option D will be very suitable answer for this particular question. Hope this is clear right now. So you can solve this kind of questions in the exam once if you practice the questions from that particular topic. That's it. So what is my suggestion here? Whether you might be preparing for EAPCET, NEET, JER, even for IPE. See, some students are only preparing for IPE, and especially in Telangana, IPE exam dates are announced. So students are in fear and started preparation for IPE only, I think so. Okay, so along with your IPE preparation, I suggest you to prepare for EAPCET also. Okay, because we have some time for IPE also, right? So during this time, you can make both preparation simultaneously. Okay, for example, if you are a class 12 student studying for IP, let us say coal dust law, you are studying for your IP from electrochemistry. See, there will be one question from electrochemistry, especially we can expect based on coal dust law or Faraday's law in EAPCET or EAPCET. So it means whenever you are preparing for your IP exam, you just solve few MCQs related to coal dust law and Faraday's law. Then there will be one question in your pocket that you can definitely attempt in your EAPCET exam also. Okay, so this is the basic approach you can follow for your preparation of EAPCET along with your IP. Hope this is clear. Right. Let us move forward with few more questions. Look at this, again very basic question. If you know the periodic table, you can answer this question also. See, here they are saying atomic number as 56. Atomic number 56 belongs to which group and which period? Very simple. See, for answering this, I will give you one simple approach. First of all, I hope you know what are the noble gas elements. We know helium, neon, argon, krypton, xenon, radon, like this right now, and their atomic numbers: helium atomic number 2, neon 10, argon 18, krypton 36 and xenon 54. Like this we can write. So now look at this, atomic number is 56 given. See, helium belongs to 18th group, all these elements belongs to 18th group, and this belongs to first period. Okay, what are the first period elements? Hydrogen and helium. And this is second period element, this is third period, this is fourth, this is fifth, this is sixth. Now see, 56 is the atomic number that comes after xenon. It means after xenon we have which group? This is fifth period is over. Next comes sixth period. So it means this atomic number 56 belongs to which group? Which period? Sixth period. How I am saying? After xenon it will comes now. See, xenon is 54 having fifth group. This is the last element of this fifth period. Okay, after this 55th element goes to the sixth period. That will be the first element of this sixth period. Okay, it means second element will be our 56. So second element in the sixth period is nothing but that belongs to alkaline 8th metal. Hope this is clear. So this belongs to second group and sixth period. Okay, I hope this approach is clear. So this is the way you can calculate or identify the periods and groups. Now look at this. Here this is over. See, A is having fourth option. Okay, A4. Where do we have A4? Yes, these two are there. Next, B, when it comes to 50. See, 50 means it is just before krypton is over. Just 50. This is 4, 5. Krypton means here you can see this is 50 means this is just before xenon. Now see, 54 is the last element. So just go back to the 50. So how many numbers you are going back? So we are going back by 4. It means it will be 14th group, because I am saying this is 18th group now. So this element 50 belongs to 14th group. Okay, 14th group means which family? Carbon family. So carbon family with period number 5. Okay, so 14, 5, 14th group, 5th period. So it will be option 3 here. So B3, only these two options are there. So option D will be a perfect answer for this question. Hope this is also clear. Yes guys, if these things are clear, you just click on the like button and also share with your friends. Okay, right. You can write your opinions in the chat box also. Feel free to discuss in the class. Okay, right. Next, look at this question. An organic compound having CHO has these percentages and its molar mass is given like this, 46. What is its empirical formula and molecular formula? See guys, all the questions which I am discussing here are PYQs of EAPCET from both AP and Telangana states. Okay, look at this. So now we need to identify what is the empirical formula and molecular formula having this composition. Okay, very simple question guys. See, even this kind of questions are very important for your IPE preparation, 11th class IPE preparation also. Okay, so there will be one question based on this model in your IPE, 2 marks. Okay, right, look at here. Organic compound having carbon, hydrogen, oxygen. See, what is the percentage? 13.13 percentage of hydrogen. Okay, out of 100 grams, 13.13 grams of hydrogen is present, you can understand. And carbon weight is 52.14 percentage. And next, oxygen weight is 34.73 percentage. See, this overall sum will be equals to 100 percentage. It means for every 100 grams, you have 13.13 grams of hydrogen. So let us make 13.13 grams of hydrogen and 52.14 grams of carbon and 34.173 grams of oxygen. Like this, we need to write first. After doing this, you need to divide these grams, this weight, with the atomic weights of these elements, so that we will get number of moles of these elements present in the formula. Okay, so what is the atomic weight of hydrogen? 1. And what is the atomic weight of carbon? 12. What is the atomic weight of oxygen? It is 16. Like this you can divide. So you are going to get some simple numbers here. See, this nearest number, this is 13 only now. So I am writing it as 13.13 as 13 for some time, for understanding purpose. And 52 by 12 means almost 12 fours are 48. So the nearest integer will be 4 will get. And here this will be 16 2s are 32 now. So nearest integer will be 2. So we got 13, 4, 2 as a ratios, right? So now you need to divide these numbers with the smallest number in the given formula, in these numbers. So what is the smallest number here? 2, right? So divide all these numbers with the smallest number, 2 by 2 by 2. So that will get oxygen 1 element and carbons 2 elements, and see 13 by 2 means nearest number I am taking it as 6. So what is the formula we got here finally? How many carbons we got? Carbons are 2, C2, and hydrogens are 6, C2H6, and how many oxygens we got? 1. So that the formula is C2H6O1. So this will be the empirical formula we got. By looking at its molar mass, see, molecular weight or molar mass is 46. Now just find the empirical formula weight. See, C2 means what? 12 into 2, not 24 for carbon atoms, plus hydrogens are 6, plus oxygen is 16. So the total sum will be 46. See, now our empirical formula weight also is equals to its molecular weight. It means our empirical formula and molecular formula are same. So now we need to choose the one which is having empirical formula and molecular formula are same. See, here option C is having C2H6O1 and both empirical formula, molecular formula are same. So option C will be very suitable answer for this particular question. Hope this is also clear, and if this is clear, just click on the like button, guys. Right. Let's move forward with few more questions. Right. Look at this. The ionic radii of sodium ion and fluoride ion are same. Is it same? See, always remember, when there is isoelectronic species, what do we mean by isoelectronic species? Elements or ions with the same number of electrons. See, sodium atomic number is 11 and fluorine atomic number is 9. So now here sodium becoming Na plus ion, sodium cation. So it means 1 electron is removed. It means it has 10 electrons now. And fluorine becoming fluoride ion, F minus. So 9 electrons, by adding one more it is becoming F minus, that is 10 electrons. So both of them are having 10 electrons now. If there is 10 electrons in both of them, then we can call them as isoelectronic species. If these are isoelectronic species, always remember the negatively charged ion will be having greater expansion of electron cloud. So size of that negative ion will be greater. More is the negative charge, greater is its size, you can remember. So now I can say this assertion is wrong because they are saying ionic radii of both ions are same. No, F minus ionic radii will be greater than Na plus ion. Okay, and next look at the second reason here, what they are saying, both Na plus and F minus are isoelectronic species. Yes, reason is correct, but assertion is false. So A is not correct, but R is correct. So you can choose option D as our answer. Hope this is also clear, right guys? Yeah, if things are clear, just mention in the chat box clear sir. If not, I am going to repeat the same explanation once again. Right. Next. Yeah, so can you try this question once, because in the yesterday's session I have explained this kind of concept. Okay, you just try to answer me this. I am looking into chat box for your answer. Yes, anyone in the chat box can answer. Yeah, if the first ionization enthalpy values of sodium, magnesium, silicon are respectively, yes, given, the first ionization enthalpy of aluminium they are asking. Very simple question, guys. Yesterday I have given for second period elements. Now they are asking for third period elements. See, what are these elements? Like we have sodium, magnesium, and the next silicon, and in between this magnesium and silicon we will be having aluminium, right? So insert that aluminium. Yeah, so like this we have silicon, next phosphorus, sulfur, chlorine, like this we have third period elements. Now what is their ionization energy order? See, we know halogens here definitely greater. Between phosphorus and sulfur, due to half filled electronic configuration of this 15th group phosphorus, nitrogen, these elements, they have more ionization energy than this 16th group. So you can write first halogens, next phosphorus, then next sulfur, then next silicon, and between magnesium and aluminium, see, due to presence of ns electrons, like s electrons, fully filled s electrons, whereas here it will be having ns2 np1. See, we can remove this p electron now easily. 3p1 electron is easily removed when we compare with this 3s electrons, because s electron is very closely surrounded around the nucleus. That is what penetrating capacity of s orbital is more. Therefore, removal of electron from s orbital is difficult when we compare with this p orbital. Therefore, ionization energy required for aluminum is lesser than this magnesium. Always remember, second period will be having more ionization energy than this third period elements, or second period elements, second group elements will be having more ionization energy than this third group or 13th group elements like boron family. Okay, right. So I can write here magnesium, here aluminium, and least is sodium. So now look at the values they have provided. See, for sodium they have provided, magnesium and silicon they provided like this. See, now we know our aluminium value will lies between sodium and magnesium. So what is the value of sodium and magnesium given? So value of sodium and magnesium are given like this. So now we need to choose the one which is having the value in between these two, because aluminium lies in between these two now, between sodium and magnesium. So where do we have between this? See, this is greater than magnesium. No, this is not the one. This is also not the one, and this is lesser than sodium. This is not the one. So we have only one option, that is option A, which will be very suitable answer for this particular question. Hope this is also clear with concept clarity as well as perfect explanation, I hope. Okay, and if these things are clear, just mention clear in the chat box. Yeah, so if not, you just mention I am going to repeat it once again. No worries here. Yeah, let's move forward then. Look at this question. Which one of the following indicates correct order of atomic size of the given elements? See, these are the elements given. We need to indicate their correct order. See, all these elements given here are belongs to second period. Second period elements, tell me what are the second period elements we have. See, we have like, I can start with the lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the second period elements, right? So now look at their size, atomic size. What we know, we are going from S block to P block, from left hand side to right hand side. What happens? S block to P block, size decreases. Okay, so P block elements will be having smaller size than this S block elements. Okay, this will be the order of size. Why it is like this? Because the ns electron, that newly added electron whatever the electron incoming electron will be added to same nth level, right? If it is entering into the same energy level, therefore inside number of protons are increasing, that protons will drag that newly added electron very effectively, therefore size becomes very small. Okay, so here you can ignore this inert gases and this will be the order, because inert gases radius will be measured in terms of van der Waals radius. Okay, right. So now tell me here, so what will be the order here we have based on this? So yeah, not the one, the next, yeah, look at this: lithium, boron, nitrogen, fluorine. Yeah, so option D will be very perfect answer for this question, right? Let's move forward with few more questions. Tell me, in which are the following the elements are in the correct order of their chemical reactivity in terms of oxidizing property? See, yesterday I have told you oxidizing property of elements and reducing property of some elements. See, I told you metals are good reducing agents and non-metals act as good oxidizing agents, because metals are having tendency to exist in electropositive nature. It means what? That metal will lose electron and become a cationic form, in metallic form, like cation, positive charged form. Okay, it means they are losing the electron. That lost electron is taken by other species. It means they are undergoing reduction and element is undergoing oxidation. So I can say this metal element can act as a reducing agent, whereas non-metals act as oxidizing agent. And here, out of these elements, fluorine is having more electronegativity. Now it has more tendency to gain the electron. Okay, therefore based on this approach we can say fluorine is more oxidizing power, and the next oxygen, and the next chlorine here, and the next nitrogen here. Okay, so we have option A as our answer for this particular question. Right. Yeah, very nice guy here. What is his name? Varinder. Option A. Yes, it is option A. Perfect, man. Yeah, you can answer other questions also, which I am indicating, which I am showing here. See, the correct order of decreasing acidic nature of oxides. Yes, can you answer this question also with the same energy I want? Answer for this. See, metals forms basic oxides, especially alkali metals and alkaline earth metals form basic oxides, except beryllium. Beryllium forms neutral oxide here. Okay, so here acidic nature they are asking. See, acidic nature of alkali metals will be having basic nature I am saying, and non-metals will be having, they are showing acidic oxide. Okay, so always remember, see here we have N2O3 and CO2. Okay, so this will be the order here. See here, this is BeO amphoteric here, and this is N lithium basic. So option D will be perfect here. Okay, see here we have first non-metal oxides, then next metal oxide here. Lithium is least here because it is basic, they are asking acidic nature. It means perfect option will be D here, right? Right, let's move forward. Assertion: the first ionization energy of beryllium is greater than boron. Yes, just now I discussed beryllium, second group elements will be having greater ionization energy than third group elements. Why? Because of penetrating capacity of s orbital electrons in beryllium causes more ionization energy. Okay, that is the reason. Okay, this is perfectly correct, assertion is correct, and reason they are saying 2p orbital has lower energy than 2s orbital. No, 2s first, see 1s electrons filled first 1s orbital, the next 2s is filled, and the next 2p is filled. Why? Because when we are talking about multi-electron system, so we will be taking n plus L rule now, n plus Bohr-Bury rule we will say. Okay, so based on that, what is the n number here for this 2s? 2, and L number, azimuthal quantum number for s will be 0. When it comes to 2p, this is 2 plus, for p it will be 1. So 3, greater the number, greater is its energy. Therefore 2p having greater energy than 2s. It means whatever the statement or reason they have provided, that is not correct. Okay, and we can go with option A, assertion is true but reason is false. So option C will be perfectly correct for this particular question. Hope this is also clear, right? Next, see, look at this question again based on atomic size or isoelectronic species I can say. Okay, look at this question once, try to answer this in the comment box. Anyone can answer? Yeah, so whenever PYQ question or numerical sessions are going on, try to answer the question before teacher solves that, so that you will get more confidence. Okay, even it is wrong, no issues, because in the next minute itself a teacher is going to answer that now. So no worries, even if it is wrong, try to answer the question before teacher solves it on the board every time. Okay, so that your problem solving skill and calculation speed will be improved. Okay, look at this. Look at this. If 4 elements with atomic numbers given as z minus 2, z indicates atomic number here, and z minus 1 and z plus 1 are forming isoelectronic species. Let us fix these elements as having z minus, see, isoelectronic species means they should have same number of electrons now. For example, here atomic number something like 12 here we have, and this is something like 11 because 1 is extra. Okay, it means from this 12 we need to remove 2 electrons, then only it becomes same here. Okay, let us make it. For example, I want atomic number 11. So what I should do here, I need to add, this becomes 10 and this becomes 9. So what I need to do in order to make same number of electrons, I need to add here electrons and here I need to remove the electron. So therefore, when we are adding electrons to this, for example, I want to make all of them as negative. For example, I want to make this number of electrons as 12. So for that, I can keep this element x as it is. I can make this as x minus, I mean something like minus 1, and this is minus 2, and this is minus 3. Something like we are doing like this now. So it means what you are getting, more the negative charge, more will be the electron expanded. So greater is the size. So whenever there is a negative charge, greater the negative charge, for that isoelectronic species, greater is its size. So I can say z minus 2 will be having largest size. So what is the order of their sizes? First z minus 2, then next z minus 1, z and z plus 1. So this will be the order of their sizes. Okay, hope this is also clear. Guys, if these are clear, just click on the like button again. Right. Next, answer me this question. Atomic radii of aluminum, silicon, nitrogen, fluorine are given here. We need to match them. Very simple now. See, nitrogen, fluorine given here, and aluminum, silicon is given here. So how can we answer? So down the group size increases. It means aluminum, silicon will be having greater size than nitrogen and fluorine. Out of aluminum, silicon, aluminum will be having greater size. Okay, so it means aluminum greater than, silicon greater than, and between nitrogen and fluorine, nitrogen greater than fluorine. So based on this, you can match them. Okay, atomic radii of aluminum should be greater. So where do we have greater value? Right, see here we have 143, 117, 74, 64. This will be our perfect answer here. Hope this is also clear. Right guys, things are clear, just click on the like button, or you can mention in the chat box, clear sir. Right, next question, again an isoelectronic species. Answer me, which are the following are isoelectronic species here? See, first of all, first option you can check here, all of them are having 10 electrons. See, magnesium 12 plus 12 atomic number, but plus 2 means remove 2 electrons. So 10, here it is 10, here it is also 10, and here it is 10 again, and here atomic number 8, minus 2 charge is there. So add 2 more electrons, 8 plus 2 becomes 10. So this is isoelectronic, and here also these things are also isoelectronic, and these are also isoelectronic. So 1, 2, 3 are isoelectronic species. So we can go with option B as our answer here. Hope this is also clear. Yes guy, yes, someone answering in the chat box. Right, option B is perfect. Yeah, next try this question, try to answer me. Yeah, so look at this. Potassium permanganate was heated at 300 Celsius. What is the weight of the residue formed here? See, first of all, KMnO4 upon heating, what happens we need to know. So KMnO4 upon heating gives K2 MnO4 and plus MnO2 plus oxygen gas is released. So this will be the residue formed here. This is a residue formed here. Okay. So for this, first of all, balance the equation. So 2 KMnO4 gives K2 MnO4 plus MnO2 plus O2. Okay. This will be the scenario here. See what they are saying, 0.1 mole of potassium permanganate is heated. Permanganate is heated at 300 Celsius. So now look at this. First of all, try to take their mole ratios 2, 1 and 1. So for 2 moles we are getting residue 1 mole and oxygen formed will be 1 mole. And now look at this. Simple way to answer this will be, if it is 2 moles we are getting 1 mole. If it is 1 mole we will get 1 by 2 mole, and this is also 1 by 2 mole, because just divide this number by 2. And they have given this as 0.1 mole. It means this one will be also, just multiply this one with 0.1, that's it. And this one also 1 by 2 into 0.1, and this is also 1 by 2 into 0.1. Now I will tell you 2 ways to answer this question. So first way here is how many moles of this residue is formed. See, 1 by 2 into 0.5 means I can write 0.1 means I can write this as 0.05 moles of this residue is formed. So 0.05 moles multiplied with atomic weight or molecular weight of this substance and molecular weight of this substance, multiply here. So that we will get molecular weight of K2MnO4 plus molecular weight of MnO2. So you will get your answer here, what is the amount of residue formed. So this is one way, and the other way here I will tell you is, see the atomic weight, see atomic weights are given and molecular weight of KMnO4 is around 158. Okay, so now what happens here is, see out of this 158, see how much it is given, 158 is given now. See, if it is 1 mole, that will be 158. See, given moles are 0.1 now, it means this is just 15.8 grams only given. Okay, so now out of this 15.8, how many grams of O2 is removed out? See, this is 0.05 multiplied with 32. Okay, so that's it. This many grams. Why I am multiplying with 32? Because molar mass of oxygen is 32. So that's it. So now what is the residue formed? See, remove 15.8 minus what is the weight of this substance. This will be you can write as 1 by 2 into 0.1 means this will be 16 and 1.6. Okay, minus 1.6. So this will be giving us 14.2 grams of residue is formed. That's it. We have 14.2 grams in the first option. So that will be our perfect answer here. Yes, even if you are student of 11th, someone in the comment box, Sir, I am student of 11th class. No issues, man. Even if you are 11th or 12th, see, whatever I am solving now, these are belongs to 11th class syllabus only. Okay, so even if you are 11th class, you just start your preparation. Okay, now you can focus on your JEE and NEET preparation. If you are BPC student, or MPC, focus on JEE advanced topics. Okay, mains and advanced topics. Okay, so right, let's move forward. Again, one interesting question. There is a similar question in JEE mains also previously. Look at this. 200 grams of 20% weight by weight urea solution is mixed with 400 grams of 40% weight by weight urea solution. What is the percentage of the resultant solution? Very simple question. Look at this. See, first whatever they are saying, 200 grams of 20%. See, 20% weight by weight percentage they are saying. 20 weight by weight percentage they are saying. See, it means 20 grams of urea in 100 grams of solution, like this. So how many grams they have given? 200 grams, no? For every 100 grams there will be 20 grams. Given how many grams? Given solution is 200 grams. So if it is 200 grams given, so the urea present here will be 40 grams. This will be the first case, first solution mixture. Okay, and second solution given is 40% of urea in 400 grams. It means 40 grams, second scenario this is, 40 grams urea in every 100 grams of solution. Okay, so now what is the weight given? Solution weight is given as 400 grams. If it is 400 grams, multiply with 4. So 40 into 4, that will be 160 grams. So 160 grams of urea in the second solution, 40 grams of urea in first solution. So total weight of urea is how much now? So 160 plus 40, that is 200 grams of urea is there in total in this mixture. What is the weight of total mixture? 400 plus 200. So total weight is how much? 600. Total weight is 600. Now what they are asking, what is the weight percentage of resultant solution? So now weight percentage of urea in the resultant solution will be weight of urea, that is weight of urea by total weight into 100 you take. So what is the weight of urea given? 200. So take here 200. And what is the total weight given? 600. Multiply with 100. Okay, so this will be 3 is a 100. So 100 by 3 we got. So this is simply, you can get your answer as 33.33%. That's it. So where do we have option? So we have option B as our answer. Hope this is also clear. Yes guys, if these are clear, just mention clear in the chat box. Right guys. Do you have any confusions here? If any confusions are there, please mention. I will repeat once again. If no confusion, give a thumbs up. Right. Next question here. Yeah. So they are saying about molecular weight and equivalent weight. Yes. See, they have given some molecules, some substances in list 1 and their equivalent weight in list 2. We need to match the substance with its respective equivalent. Very simple. When it is given, a salt is given. See, this salt Na2CO3 is given. So when it is a salt, just take what is the total positive charge it has or total negative charge it has. See, we have 2 sodium ions now, 2 Na plus ions are there. So what is the total positive charge? 2 into plus 1. So total positive charge will be plus 2. Or what is the total negative charge? Here we have carbonate ion, which is minus 2. So we have one carbonate ion, each one is having charge as minus 2. Just take its magnitude without any signs. So it will be 2. Okay. So these are called their N factors or valency factor. Whatever the charges we got, the values we got, those are called as N factors. Okay. So now whenever they are asking about equivalent weight of a substance, take its molecular weight divided by this N factor, whatever the number we got. So what is its molecular weight given here? M. By its equivalent weight means by N factor, M by 2. So for first option A here, M by 2, A 3. Okay. Similar way, when it comes to this potassium permanganate, KMnO4 in acidic medium they mention. So in acidic medium, KMnO4 converts from +7 oxidation state is there, converts to +2 oxidation state. What is the N factor changed here? 5. So its molecular weight divided by its N factor. How much N factor? We got a 5. How I am saying 5? See, 7 is converted to +2. It means how many electrons gained here? The change in number of electrons are how many per atom, per this manganese atom. 7 is converting into 2 means 5 electrons, no? So 5 is its N factor. So M by 5. So B 1. Next. See, here potassium dichromate is there. So in this potassium dichromate, chromium oxidation state is +6. So this +6 converts into +3 in this acidic medium. Okay. How many chromiums are there like that? 2 chromiums are there. Each chromium is converting from +6 to +3 now. So change in number is how much? +6 to +3. It means 3 change now. For 1 chromium it is 3. So for 2 chromiums into 2. 2 into 3. So total N factor change is 6. So for this particular species, you can take molecular weight divided by 6. Where do we have that kind of option? Yes, C4, that's it. Okay, and definitely D will become 2. Okay, so here +7 converts into MnO2 form. MnO2 means how much here? +4. +7 to +4 means 3 now, n factor change, that's it, m by 3, that's it. Everything is clear now. So now you can say me the option which is having this kind of matching. See, A3, B1, C4, D2. So option A will be perfect answer for this question. Hope this is also clear. Right. Let's move forward. Can you try this question again based on equivalent weight again? 12 grams of an element react with 32 grams of oxygen. What is the equivalent weight of that element reacting here? Simple question. Let us say consider element, the 12 grams of element they are saying now. Let us say that element X which is reacting with our oxygen O2. Okay, some product is formed, no need of discussion about that product. Okay, how much they are saying? 32 grams of oxygen they have taken, that is reacting with 12 grams. Okay, 12 grams of that element X is reacting with 32 grams of oxygen. See, equivalent weight is that weight of any substance which reacts with 1 gram of hydrogen or 8 grams of oxygen. Okay, so now 8 grams of oxygen, what is the amount of substance this substance is reacting, that will be its equivalent weight. For 32 grams they are saying 12. So for 8 grams of oxygen you can consider this as x grams. Find the value of x, very simple. So x, use unitary method, 8 into 12 by x into, 8 into 12 which is equals to x into 32. So x will be 8 into 12 by 32. Okay, this will be 4 times and this will be 3 times. So what is the x value here? 3. So this is 3 grams. What is the equivalent weight of this element X here? That is 3 grams. That's it. Option D will be perfect answer here again. Hope this is also clear. Right. Let's move forward. So answer me. Observe the following reaction and the equivalent weight of nitric acid in this reaction they are saying, because equivalent weight varies from reaction to reaction and condition, whether it is taking place in acidic medium, basic medium, all these factors are there. Okay, so now what I told you, whenever they are asking about equivalent weight, first of all find valency factor. How can we find valency factor? Change in the oxidation state. Here what is the oxidation state of nitric acid, nitrogen? +5. So this +5 converting into +4. So it means what is the change? Only 1 now. So 1. How many nitrogen atoms? 1 only, into 1. So its n factor will be 1. So its n factor will be 1 means, so what I can say, equivalent weight will be equals to its molecular weight divided by n factor. N factor we got 1 now. So molecular weight divided by 1. So where do we have molecular weight divided by 1? First option will be the very suitable answer for this question also. And next, look at this. I am asking you one extra question here. What is the equivalent weight of iodine in this reaction? I2 is converting from I2 to HiO3. So I2, it means 0 oxidation state converted into HiO3. So minus HiO3 means here plus 5. So what to do? First find what is the change in n factor. Okay, there are 2 iodines, 2 into what is the change? 0 to 5, it means 5. So you got n factor as 10. So 10 means what I told you, molecular weight of that I2 divided by its n factor. Molecular weight of I2 divided by 10 will be our answer. Hope this is also clear. Right. I hope you got what we are doing in these calculations, like finding equivalent weight, finding n factor, things are clear, I hope. Okay, next. Okay, so can you try this question similar, whatever the way we have solved? So you can use this. If you are unable to answer this, I will explain this question in the upcoming chapter. Okay, in redox reaction otherwise. Okay, you can try. If you are able to do this, it's really good. If not, I will explain. Okay, now Again, these questions whichever I am showing now, these questions were discussed in the previous sessions. Previous sessions means what? I am saying that this is our day 5 of EAP set. Okay, it means in the day 2 and day 3 and day 4, in these 3 sessions I have discussed theory plus PYQs of some basic concepts of chemistry, which includes mole concept and periodic table and properties. So from those questions in those sessions I have covered this question. Now you can try this question, whatever the homework question I am giving you now, you just try this. If you are unable to answer this, watch my previous sessions. Okay, there you will get this solution. Okay, so this will be there in the session 1, I mean day 2, session 1. Okay, you can get answers for these questions in day 2 of chemistry EAPCET 2026. Okay, right. So this question also answered in that. If you are unable to get the answer for this, you can get it from that video. Okay, next. And again this question also solved in the day 2 session. Okay, you can try this. If you are really unable to answer, go and watch that. Next. Again this one also same, and here also same. All these questions are solved questions only. Okay, this one also. The next. Same. Yeah. So what is my intention here? So in complete session till now we have completed 4 sessions on concept discussion. Okay, first day I told you like how to approach the questions, what is the way to prepare, all these things I have shared. And in the next 4 sessions, in last 4 sessions I have covered 2 chapters now. So within these 2 chapters and today's discussion, in total of almost 35 to 50 questions from each chapter were solved. All those questions are PYQs only. Okay, so hope you will use these sessions very effectively for making your preparation effective. Okay, right. Okay, you should solve all these PYQs so that you will definitely gain the confidence. Okay, and you can able to solve questions from EAPCET, JEE and NEET also. Okay, next. Look, all these questions are solved questions only. So these questions I am sharing just to make you solve. Just pause the video and try to solve all these questions. Consider these as a homework questions which I am giving here. Consider this whatever the questions I am projecting here as homework questions, and you can answer them in the chat box if you know the answer. If not, go and watch the previous sessions that I have covered answers for this. Yeah. This session, whatever periodic table questions you are seeing, that will be in the day 4 session, I mean last session. Yes, so these are the questions I am just giving you as a homework questions. Almost around 10 to 15 questions as given as homework. You just solve all those questions. You can write your answer in the chat box. Definitely I will look into your options, I mean whatever the answers you are giving in the chat box, and I will definitely reply if these are correct or not. If it is wrong, how is a better way to answer them. I will definitely put my suggestions in the chat box. Okay, so try to answer them in the chat box. And if you like the content, please share with your friends, those who are preparing for these exams. Okay, and thank you for watching. Stay connected with this NEET World channel. Thank you.